My name is Doug Horton. I'm a technology consultant to the food service industry. I'm speaking to you today from the Gas Cooking Technology Center at Piedmont Natural Gas in Charlotte, North Carolina. With me today is Tom Struzis, who is the developer and manager of this center.
We have entertained many national chains over the past number of years, as well as chefs, local operators, school food service professionals, and others within the food service market nationwide in equipment evaluations, menu development, energy applications, and of course, operating efficiencies of equipment and what best suits today's operator for their particular menu item.
Our objective today is to demonstrate a typical kitchen ventilation system that we might find in restaurants around the country. This hood is 20 feet long, and we call this a short circuit type hood, and under it can be a variety of appliances, either electric or gas. This hood is nominally 4 feet deep in order to provide overhang over the commercial gas appliances. Inside the hood we have exhaust filters, which are a baffle type. We have a fire suppression system. This is a liquid system. And then inside the front of the hood we have registers that provide the internal or short circuit makeup air. We're going to demonstrate operation of the hood with the appliances in a ready to cook condition. So we're turning on the back 3 burners of the gas range. We're turning the charbroiler on full, and the deep vat fryer has one vat turned on set for 350 degrees. To demonstrate hood performance in the idle condition, I'm going to use a small device called a TT puffer. The smoke that I'm emitting right at the front of the hood is not being drawn into the hood. Rather, it's spilling out of the hood. This indicates that potentially products of combustion, humidity, cooking odors, and convective heat can spill out of the hood instead of being captured by the hood. Our cooking is becoming a little more vigorous, particularly as the fries continue to give off steam, and we're getting more and more smoke from our charbroiler. We can still use the TT puffer, and we can see a great deal of rollout. And what's happened here is that the amount of effluent, the volume of effluent coming up from our appliances has increased while we're cooking. And so not only do we have the spillage that we had in the idle or ready to cook condition, but we now are spilling from the additional effluent from cooking. Now the key to understanding here is that this hood is rated for 250, as I mentioned, out and 175 per foot in, which gives us a net exhaust of only 75 CFM per linear foot. And that's our real problem. The net exhaust is what really counts in removing the effluent from our cooking process. And the mass volume of our effluent is greater being generated by the appliances than is being removed by the exhaust system. We've released a great deal of smoke out of this hood into the classroom, and we can see this smoke hovering near the ceiling. It's truly amazing that this is a hood that was just installed 3 years ago. It's a state-of-the-art hood. This is a kind of hood that's being installed in kitchens every day, but it doesn't work. What we've done now is flip a switch that has moved the makeup air from these registers at the front of the hood to registers in the back of our classroom. And that has significantly increased the performance of the hood, so that we now see this effluent coming up from the charbroiler. We see it recirculating in the hood. It comes back down this way. It tries to spill out, but because we have this air moving this way now, it now captures substantially all of the effluent coming up in the cooking process. What's interesting here is that this hood carries an Underwriter's Laboratory nameplate that rates it for 250 CFM per linear foot exhaust and 175 CFM per linear foot short circuit makeup, providing a net exhaust of only 75 CFM per linear foot. Clearly, this hood did not operate at the UL listed values. But by flipping the switch that we installed for this demonstration, we moved that makeup air from inside the hood to out in our classroom. That changed our net exhaust from the 75 CFM per linear foot to the 250 going out through the exhaust filters. and the performance of the hood became satisfactory at that point. So remember, if we learn nothing else today, it's the net exhaust that counts. We learned that the left-hand portion of the inefficient short-circuit hood has been replaced by a more modern and more efficient design. In the new design, the hood is exhaust only with no internal makeup, and it's 5 feet deep instead of 4 to provide greater overhang over our appliances. The most significant difference, however, is that the makeup air is provided through this linear perforated supply plenum, as the manufacturer calls it. This plenum runs along the 10-foot front of the hood, plus 1 foot at the corner, plus 5 feet at the side. Our exhaust rate remains 250 CFM per linear foot. The makeup air rate is 150 CFM per linear foot, and multiplied by 16 feet, we are able to provide almost all the makeup air through this perforated supply plenum. Additionally, the air coming through the perforated supply plenum is normally untempered. We rarely have to cool it, and if we have to heat it, we only have to heat it below outdoor temperatures below about 40 or 45 degrees. This provides substantial savings because even though we were able to make the short-circuit hood work by moving the makeup air to the back of our classroom, that air would become part of the heating or cooling load of the room, and this does not. We'll repeat the cooking test from before to demonstrate the efficiency of the new hood design. As cooking proceeds, the effluent from the ground beef patties and from the fries increases. We can see that virtually all of the effluent from these two cooking processes is being caught by the exhaust hood. Using the TT puffer, we can see that most of the smoke from the puffer is remaining in the hood. It seems that the perforated supply plenum makeup air is providing a very gentle, low-velocity airflow into the hood. In fact, it seems to be a gentle air curtain effect. Tom has removed the fries, but the ground beef patties are still cooking vigorously and releasing a great deal of smoke. But that smoke is remaining in the hood. With the new hood design, we've learned that it's not only the net exhaust that counts, it's also having a deeper hood and having a better makeup air design and location.